Dear listeners, I am very pleased to present to you today our work entitled A Value-Sensitive Design Approach for Designing AI-Based Worker Assistance Systems in Manufacturing. Together with my colleagues Harald Bauer and Marianne Tjels-Ziegler from TUM, with Erwin Rauch from the Free University of Bolzano and Steven Umbrello from the Technical University of Delft, I examined and investigated to what extent an existing AI-based workplace already meets the requirements of a human-centered and value-sensitive design, and which aspects would still need to be improved in the future in this workplace. I would like to briefly present you our findings in the next few minutes. In order to be able to produce efficiently and more sustainably, manufacturing companies are integrating more and more digital and AI-based applications into their production systems. At the same time, however, people and human operators are still very often working in these environments, which means that the use of assistance systems and the interaction between human operators and technology is increasing sharply in these environments and production systems. The need to make those technologies as human-centric as possible is also increasing as a result. Technologies are never value neutral, which means they almost always offer the possibility of interaction and thus either support or constrain certain social factors. They especially constrain those factors if they are socially not very compatible designed and if their design is not taken into account. In addition to ergonomic design, the value-sensitive and socially sustainable design of production systems will therefore also play a major role in the future. In current, traditional production systems, however, those ethical aspects usually do not yet play a major role. Likewise, in the area of work planning and workplace design, there are also no methods applied in the industry, not yet, as to how exactly ethical aspects can be taken into account. The design methodology of value-sensitive design could offer a starting point to address these aspects in the future. What is value-sensitive design? Well, it basically is a three-partite framework in which a work system is analyzed and examined from these three perspectives, which are a conceptual investigation, where the values from philosophical literature and also the values explicitly elicited from stakeholders are determined and investigated. The second dimension is the technical investigations. Here, the technical limitations of the technology itself and the fact how they support or constrain identified values are examined. And the third dimension is the empirical investigation. Here, stakeholder values are empirically evaluated through sociocultural norms, and then they are translated into potential design requirements. So these three dimensions interact. They can be chosen over the, let's say, the prioritization in which you examine this dimension can be chosen freely. So in our case, we had a specific use case, which was a AI-based assistance system in the laboratory of Erwin Rauch at the University of Bolzano. And what we did first, we did the technical investigations of this workplace and analyzed how in detail the workplace is built up, which technologies are used. And you can see here a picture of the just mentioned workplace, and we see in the fields the different technologies which are used. So we have, for example, a cobot which is assisting as a third hand for the human operator. Therefore, we have, of course, certain human-machine interactions. We have an AI-based prediction of the operator's intentions. So basically, a camera is watching the operator and his movements and therefore can predict what he's doing next. And then the cobot interacts or reacts to this movements and helps the operator. Therefore, we have lots of sensors which collect data at the workplace. We have a chatbot which can be used for retrieving information very quickly. And we have an AR assistant which can visualize different information pieces for the operator, as for example, which variant has to be assembled next. So this was the first step. We analyzed the existing workplace in detail and examined the different technologies and how they are set up and how they also interact with the human operator. This technical investigation was followed by an empirical investigation, and in this empirical investigation we mainly focused on a detailed stakeholder analysis. This means we checked who are our direct and also indirect stakeholders at the workplace. So direct stakeholders are basically all people or all human operators who are in a direct interaction with the workplace, with the system, so basically during the production. And here we have identified three basic groups of stakeholders. So the operator of the workplace himself or herself. Then we have the operators nearby, which means, for example, the persons on the following workplaces. Then we have technicians or maintenance staff who is also interacting with the system. And we can, for example, also have like a supervisor as a direct stakeholder if the supervisor is working at the workplace, him or herself too. And all those direct stakeholders, they have different ways of interacting with the system, which we describe in detail, and they also have different ways of interacting with other stakeholders, which in this case are mostly other colleagues. Next to the direct stakeholders, we also analyzed the group of indirect stakeholders, which are those people who are impacted by the technology without directly interacting with it. So that is, for example, the worker council in a manufacturing company who is receiving or giving information concerning the examined workplace, but is not directly working with the system. And also those groups have different interactions either with the system or with other stakeholders and colleagues. So the results for these empirical investigations were very individual requirements profiles for all stakeholders, and we could also determine the different work tasks and the essential interactions. The workplace requirements we found here were typical workplace requirements as they can be found in many smart factories, so especially requirements like flexibility, the adaptability to changes, professional competence, teamwork, and also, of course, system competence. The third step in our value-sensitive design approach was the conceptual investigation, and here we analyzed which human values were particularly relevant in the examined use case and how those were either promoted or violated by the assistance system. These results were then used to derive concrete recommendations for further improvement actions. So here we basically found that there are certain universal human values like well-being, justice, and dignity, which always play a major role in the workplace design. And for our special workplace here in the use case, we found out that meaning and identity for a human worker is very central and is also very intensively attached to the organization of the work, to the job itself, and also to the tasks and the interactions. So literature says that in order to identify oneself with a job or with a work task, it is necessary to experience oneself as autonomous, competent, and related. So this means in order to feel like we are doing meaningful work, it is necessary for human beings that the work we are doing makes a difference, or the outcome of the work we're doing makes a difference to other persons, which means that we do not like to be involved in tasks which seem to have no sense or which seem to make no difference. If we experience such feelings during our work tasks, this can lead to like severe problems with motivation and also with maybe depressions and stuff like that. So the goal of value-sensitive design is always to create a cooperative, integrative, and inclusive design for manufacturing workplaces. So basically, we could use those results in the conceptual investigation in the next step when we stepped back to the technical investigations and examined how we could improve the already existing workplace with the results from the conceptual and the empirical investigation. And here we found that in order to improve the listed values here on the left-hand side, we have to address certain aspects in the original design as it is now. So for example, let's take the value meaning. In order to create more meaning for the human operator at the current workplace, it would be necessary to show him or her more what are the results of the work you're doing here, and how does these results influence or influence other people. What is the meaning which is created by the work you're doing? In our system here, in the assembly workplace, this could, for example, be realized pretty easily by showing pictures of the final product, so that the worker can always have the feeling, I know what I'm doing and I know what the work tasks I'm fulfilling here at this workplace will lead to in the end. Or let's take the value of well-being. So far at the workplace, there's no human interaction between operators or between the operator and supervisors. Everything is just happening in interaction with the robot or the system. So if we're talking about a future improvement or a future redesign of the workplace, it would be really helpful to integrate more human interaction with other people. So for example, by using headsets for communicating with other workers in other assembly lines, for example. Or we could integrate interaction with the technology, which is the system, for example, by voice control, so that the interaction feels more natural for the human worker. So at the end of my short presentation, I would like to summarize our results and also critically examine them and point out identified limitations. In principle, what you just heard now was that we analyzed and ameliorated our existing AI assistant assembly workstation with the help of the value-sensitive design methodology. We did a technical investigation in the first step and derived optimization methods for a future redesign. These optimization measures were based on the results from our empirical analysis, where we summarized the main functional requirements for all stakeholders, and the conceptual investigations, where we focused on identifying and defining the ethical values which are the main or the core of a future workplace design. In principle, the methodology of the value-sensitive design could be applied very well to our existing workplace, and thus we could also find starting points for future improvements. However, it would of course be desirable to draw on these findings at a very early stage of workplace planning and design, so not only in a stage where the workplace is already existing. However, for industry, this would mean that the appropriate competencies for ethical production system design would have to be available among the work planners and the engineers, which is currently often not the case. But there's also still work to be done in academia in this field of research when it comes to concrete methods on how to integrate human value concepts into workplace design. There's still quite a lot of work and research to be done. So we also see as an outlook, we see that this field of research is really important for the future manufacturing systems, and we see that there should be research done in terms of methods for including and focusing ethical values. But so far it's also very helpful and necessary to validate the applicability and the effectiveness of the value-sensitive design approach in further detailed case studies. These are our first results, and I'm very happy to answer your questions during the live conference. Thank you.